Okay, I'm going to have a 10-minute talk about Xthin versus compact blocks. It's going to get quite technical, and I hope most of you will be able to follow. I was going to assume everyone knows Xthins because there was a presentation about, supposed to be a presentation about Xthin before. I'm still going to assume that. So, my name is Dagur. I am Dagur on GitHub. I am Icelandic, but I live in Norway, where I have lived most of my life. I am a father of two and a programmer by day job, and in my spare time I often hack on Bitcoin XT. I have not invented either of the technologies. However, I have implemented both in the Bitcoin XT client. So I feel I am able to talk about them. So to begin with, I'm going to give a 2-minute crash course into compact blocks, and I'm going to do so by comparing the protocol basics to Xthin. And again, I assume you know how Xthin or extreme blocks work. So when two nodes connect to each other, they have to announce to each other what services they support. Xthin announces its service using a service bit in the initial handshake. Compact blocks does it right after the initial handshake by sending a send compact message. When a node is requesting a thin block, it'll send a get data message. In the case of Xthin, it'll send get message thin block. And in the compact block case, it'll send a message compact block type message. So very similar. This one is actually a bit too similar because message thin block and message compact block have the same identifier. So when I discovered this, I opened an issue on a course GitHub. It was quickly closed as being too late. There was a release candidate out, and even though Xthin blocks had been on the network for over 6 months, they did not see it as their fault because the BIP process had not been followed. This provoked many, and Bitcoin being Bitcoin quickly turned into Reddit drama for a couple of days. News.bitcoin.com picked it up, and I like this comment made on the issue by a random person. Has the Bitcoin development community broken down to the point where we can't even agree on an enum value to use? Yes, I guess so. Anyway, the identifier conflict is okay. It is a bit more work to support both, and you have to ignore a non-essential requirement in the BIP 152 compact blocks. So back to the crash course. Oops. Sending compact blocks. So when you're sending thin blocks, if this block is a Xthin block, you send a Xthin block message. If it is a compact block, you send a compact block message. When you're re-requesting, if that block is missing any transactions, the receiving peer will have to re-request those transactions. And Xthin does this with get xblock tx. Compact blocks does this with get blocks txn. And when receiving the reply from that message, it's also very similar. So this is a comparison of the two protocols. Sorry. So to summarize, if you understand Xthin, then you understand compact blocks. This is just a modified diagram from the BIP 152 where I replaced the names of the different messages. So it's the same technology. However, there are differences, and to make this talk interesting, I will talk about these differences. So the rest of the talk is going to be about how they differ. When it comes to announcing support, Xthin uses service bits, and service bits are useful for finding peers that support some niche service. And Xthin nodes are quite scarce compared to core nodes. Therefore, it makes sense for Xthin, in my opinion, to use a service bit. Compact blocks would not, Compact blocks would benefit less because there are plenty of core nodes, but also because core, being the majority client, was able to bump the protocol version, making that a good enough identifier to identify other compact block nodes. Anyway, this difference has little significance. And as I said, in my opinion, it makes sense for Xthin to use a service bit. It would make less sense for compact blocks to do so. As for requesting thin blocks, here is one of the bigger differences between the protocols. Xthin does send a filter along with its block request. Compact blocks does not do this, and the filter is used to tell other nodes what transactions are in the requester's mempool. So by adding this filter, you increase, at least in Bitcoin's unlimited case, the request by 5 kilobytes, or the protocol maximum is 36 kilobytes. So when a node sends a thin block, the transactions, the transaction the receivers is thought to be missing will be bundled into the thin block. This is also known as pre-filled transactions. And if the sender sends the correct transactions, it'll mean a good pre-fill accuracy. If it misses any transactions or sends too many, it leads to low pre-fill accuracy. And a symptom of a low pre-fill accuracy is that the receiving node has to send a re-request for the missing transactions. In the case of Xthin, the rate for re-requests is at 1%. In the case of Bitcoin Core 0.13, it is about 60%. There is huge improvement potential because they have not really implemented a good algorithm for finding those pre-filled transactions that are needed. So, but in time, I would like to, it'll be interesting to see if they can achieve anywhere near the same accuracy. Any thin block implementation will benefit from the two peers having a similar mempool policy. And a similar mempool policy means that when a transaction needs to be thrown out of the mempool, that both nodes will throw out the same transaction. Xthin, being a thin block technology, will naturally also benefit from a similar mempool policy. However, due to the filter, it is not necessary. As for compact blocks, the sender has to guess which transactions the receiver is missing, so you will need a similar mempool policy. It is, in my opinion, worth the extra byte to have this filter. It is also my opinion that Xthin is more cross-client friendly due to this filter. The reason I state that is because any node implementing compact blocks would also have to adopt Core's mempool policies. Both compact blocks and Xthin blocks contain a list of all transactions where each transaction is shortened to 64 bits. In the case of compact blocks, they also obfuscate these transactions to defend against a theoretical hash collision attack. As for when compact blocks adds a pre-filled transaction to the block, it also adds its index in the block. This way they don't have to send the transaction hash twice. They can instead send the list plus the index of the pre-filled one. And this saves them about 1 kilobyte per 21 pre-filled transactions. So they shave off a few bytes there. As I said, transactions have a fixed position in a block. Compact blocks also uses this in re-requests. So instead of sending a list of hashes of transactions they need, they send a list of indexes. And this saves them about 1 kilobyte per 21 transactions. And it is, in my opinion, a good idea to use the index like this. It is also my opinion that the way compact blocks have encoded this index is a bit complicated, needlessly complicated. As for scalability, Xthin can scale as is. Compact blocks, at least in the current implementation, will get an issue when transactions reach about 2 and 16th, or about 65,500 transactions. That is equal to 38 megabyte blocks, or maybe half that if you have a carefully crafted block. This is because they use a 16-bit integer for their index. However, due to the encoding, you can hack around this problem. It has not been done yet today. Or you can simply upgrade the protocol to use int32, which I doubt they will want to. However, but that brings me to upgrading the protocol. Xthin does not have a defined upgrade mechanism. Compact blocks define version in their handshake, and if two nodes do not match the version, they will ignore each other's compact block support, meaning this is a method of being forward compatible. As for SegWit compatibility, it's not so interesting. Well, compact blocks have implemented it in their version 2, so in the next version, Xthin can also add SegWit compatibility in a similar fashion. It's a very small change. So both Bitcoin Unlimited and Core have implemented a similar low latency relaying. So back in the old days, before we had infs, nodes were pushing full blocks directly to each other. So we're back to doing that, except the blocks have gotten thinner. Compact blocks has what they call high bandwidth mode, which is quite similar to expedited. Here is the Bitcoin Unlimited version. Here is the compact block version. In the Bitcoin Unlimited version, a node receives a block. It does a basic verification, then forwards it. Afterwards, it does the full verification. In high bandwidth mode compact blocks, it's similar. You receive a block. In this case, you do a full verification and then forward it. So you announce a new block with a thin block instead of a inf or in a header. Another difference is how the low latency relaying is set up. Compact blocks does this by requesting high bandwidth mode from 3 semi-arbitrary peers. As for expedited, it is done in the configuration by the node operator. So pros and cons: expedited, perhaps a bit faster, but needs manual setup. Compact blocks, automatic setup, perhaps a bit slower. I'm going to skip this due to time. So my conclusion: there isn't really much difference between the two protocols. In my opinion, it is a bit more complex to implement compact blocks. Compact blocks manages to shave off a few bytes in its network requests. I doubt there is any performance difference between them. I hope someone will do a comparison. Overall, I think they're both good protocols. Thank you.